If the area of the triangle with vertices this is 4 square units, then the value of x is. Once again we can use the determinant method. X 0 0, I'm sorry 1, then 1 1 1, 0 2 1. Okay, and half of that is equal to 4, so this is equal to 8. So just solve it. X 1 into 1 minus 2, so that is 1 minus 2, that is minus 1. Then leave this, plus 1 2 minus 0, so that is 2, and this entire calculation is 8. So minus x is equal to 6, or we just have to take the modulus, so modulus of x is equal to 6. So okay, we have to find out the value of 6, so no need to take the modulus. X is equal to minus 6. Okay, pretty simple. The triangle formed with A, B, C as vertices is, so we have to find out whether it is an equilateral triangle, isosceles triangle, right angle or right angle isosceles. So for that what we can do, simply we can find out the slope of AB, BC and AC. So AB slope will be 0 minus 8 by 5 minus 3, that is 2, so that is minus 4 slope of AB. Then BC slope will be 7 by minus 6. Then AC slope will be minus 1 by minus 4, that is 1 by 4. So you can see product of these two, AB and AC, that is minus 1. That means AB and AC, they are perpendicular to each other, right? So A, B, AC, they are perpendicular to each other. Okay, so now this is clear that it is a right angle triangle, but still we have two options, because maybe it is only right angle triangle or it is right angle isosceles triangle. So that also we need to find out. So just quickly find out the length of AB and AC. So it is 5 minus 3 2, so 4, that is plus 8 8 8 just 64, so it is root 68, and this is 4, that is 16 plus 1, so that's different. So AB is not equal to AC, that means it is only a right angle triangle but not an isosceles triangle. Okay, I'm just using distance formula to find out the length of AB and AC. If the points this are collinear, then K is. Okay, if the points are collinear, suppose these are A, B and C. If the points are collinear, their slopes should be same. So you can find out the slope of AB and slope of BC and then equate them, right? So I just do it. Slope of AB will be 2K minus 2 plus 2K upon minus K plus 1 minus K. That is slope of AB. And slope of, we can take AC also, we can take BC, any of them can be taken. Suppose I take maybe BC. So 6 minus 2K minus 2K. So 6 minus 4K by minus 4 minus K plus minus K minus 1, right? 6 minus 2K in denominator, minus 4 minus K plus 1, so it will be plus K minus 1. Right, so this K and this K is cancelled. Now to make the problem simple, instead of going for cross multiplication, what you can do, you can just put up the simple values from the options. So I have two simple cases, that is minus 1 and 1 from here. So just go with the, say, minus 1. So it is minus 6 by 3, so that is minus 2 left hand side. 6 plus 4, 10 by minus 5, that is also minus 2. So minus 1 is the correct choice. Okay, so that will be easy for you to put up the values from options. If minus 1 is not satisfied, you should first check with 1, right? Generally in competitive exams the values are simple. Now we have this problem, a very interesting one. A, B, C, D, E, 5 coordinates are given, are the vertices of pentagon A, B, C, D, E. Then we have to find out the area of this pentagon. So just see how we can do it. What I'll do, I just try to mark the points on the coordinate plane, right? Just get a rough idea. Okay, Now the first point is 0 0, so this is 0 0. Then we have 12 0, so somewhere here 12 0. Then we have 12 2, so immediately just above this will be a straight line 12 2, right? This is perpendicular to this because x coordinate is constant, right? So this is 12 2. Then we have 6 7, so 6 must be somewhere inside but on the above, so that is suppose 6 7. Okay, then we have 0 5, so 0 5 that should be over here. This is 7, so 5 should be bit down, that is 0 5, and this is 0 0. So we just have to, I just do it neatly for you. See, in your exams you don't have to draw that much neat diagram, it is just for your convenience so you can understand the method properly. I'm just making a neat diagram over here. Now we have to find out the area of this pentagon. You can very well see there are 5 vertices, 1 2 3 4 and 5. Now if we start making triangles, it will be difficult for us to find out the area. So what we can do is, to make it very simple, what I do is I just draw a line over here like this. A straight line that is passing through 0.67, then a vertical line that is passing through these points, right? Okay, now what? I can find out the area of this rectangle and then can deduct the area of this triangle and this triangle. So I'll be able to get the area of this pentagon, right? Now see, for that you should be able to mark these points very smartly, very carefully, I can say. Now this entire length is 12 and this entire height is 7, right? So area of this rectangle, that is this particular rectangle, is 12 into 7, 84. From that I need to deduct the area of this triangle. Now this height is what? From 0.5 to 0.7, so this height is 2. From this point to this point, this length is 6 because x coordinate is 6. So area of this triangle is half of 6 into 2, that is half of 12, that is 6. Similarly, I can deduct the area of this triangle. So this length from 2 to 7, this is 5. From this point to this point, so this is from here to here, it is 6. From the entire length is 12, that means this remaining part is 6, right? So area of this triangle will be half of 6 into 5, that is half of 30, that is 15. So 84 minus 21, that is 63 will be the answer. Okay, see, I marked the points carefully. Just take care that 6 should be inside before 12, right? So you just get the around idea of the length. Okay, so this way you can solve this problem very easily. If at all you start making various triangles like this and then this, the problem will be difficult for you to solve in that limited amount of time, right? So just note it down. Now lines meet in the common point. Now that problem is really simple. You don't even need paper and pen to solve this. See, if in the options we have the point that is the meeting point of this line, that means that particular point should satisfy all the 3 lines, right? So what we have to do, we just check one by one whether they satisfy the line or not. Suppose I take 1 2, so 1 minus 2 is not equal to 0, so that's ruled out. Then 2 minus 2, that is also not equal to 0. 3 minus 1 minus 2 is 0, so that can be the correct option. Again 1 minus 1 minus 2, that's not 0, so that is ruled out. No need to go for the further verification, like you know, there is no need of putting 3 1 into other equations as well, right? Because all the 3 options are ruled out. So I hope you are clear. For the triangle whose sides are along the lines x is equal to 0, y is equal to 0 and x by 6 plus y by 8 is equal to 1, the incenter is. So what we'll do, we'll just draw a rough figure over here. Now this is the line where y is equal to 0, this is the line x is equal to 0, and the third line where x intercept is 6 and y intercept is 8. So this is that line. So this is the triangle in the question which is discussed. And we have to find out the in center of this triangle. That means precisely we are having a circle in this triangle and we have to find out the radius of this circle. Okay, now listen to me carefully. See, this is the center of the circle. This point or this height is 8, and from this point to this point this is 6. Now since this angle is 90 degree and this length is equal to this length is equal to this length is equal to, all the four angles are 90 degree, because from center if we drop from on the tangent we can drop a perpendicular, and that is equal to radius of the circle. So this is radius, and this angle is 90 degrees. So this, all the four lengths are equal, precisely it is a square. Now coordinate of this point is r0, right, where r is the radius of the circle. Coordinate of this point is 0, r. Again r is the radius of this circle, so this length and this length is equal. That means coordinate of this point should be r and r, that is this length and this length, right? That means the coordinate of in center should be, the x coordinate and y coordinate should be equal. So that's just one option there, that is this. Okay, so this is the correct answer. But again further we'll discuss the concept. So how can we solve this problem? See, we have discussed a formula in our geometry session, that is radius of in center is area of the triangle by its semi-perimeter. So this is the formula that we have discussed in our geometry sessions, and you might have done your geometry sessions by now. So you must be clear with this formula, that radius of in center is equal to area of the triangle by its semi-perimeter. Now here this length is 8, this length is 6, that means this length must be 10 using Pythagoras theorem. So area will be 8 into 6, 48 by 2, 24, and semi-perimeter is half of 8 plus 6 plus 10, that is 12. So this is 2. That means r is equal to 2. That means radius of this in circle is 2. That means this point should be 2, 2. That means this length is 2, this length is 2. That means the coordinate of in center must be 2, 2. This is one more way to find out the answer. So if there are two options for having same x and y coordinate, then you can go this way as well, right? So here I have used the concept from coordinate geometry as well as the normal geometry. So when you are appearing for competitive exams, definitely you must be having all the knowledge. So sometimes in a single problem you can use the concept of trigonometry, you can use the concept of geometry, you can use the concept of even coordinate geometry, right? So I hope you are getting this. Now that's an interesting question, frequently asked in competitive exam, these sort of questions. Here the area enclosed by this set of lines. See here, modulus of x and modulus of y is there. So precisely we'll be getting 4 equations, right? Do not get confused. We will be getting 4 equations, and the 4 equations will be 2x plus 3y less than equal to 6, 2x minus 3y less than equal to 6, minus 2x plus 3y less than equal to 6, and minus 2x minus 3y less than equal to 6. So these are the 4 equations of line we will be getting. So out of these 4 equations we'll be getting 4 lines, and these 4 lines will make a quadrilateral, and we have to find out the area of that quadrilateral. Right. Now the important thing to be noted down over here, so you can save your time in exams. I just draw one single line. 2x plus 3y is equal to 6, right? So 2x plus 3y equal to 6 when x is 0, y is equal to 2. So this is one point, and when y is 0, x is 3. So this is other point. So equation of this line will be, this line can be drawn as like this. Okay, now 2x plus 3y is equal to 6, and this is 2x plus 3y is equal to minus 6. So this line and this line, they will be parallel to each other, right, in this same manner. this way. Okay, so coordinates will be, this is 3 0, then this will be minus 3 0, this is 0 2, then this will be 0 minus 2. Similarly, the other two lines, they will also have the similar concept, so they will be getting they will be having lines like this. Once you are clear, then you don't have to draw all the lines. So this is one line, it will match over here, and this is the other line. Okay, so if you draw the diagram neatly, we'll be precisely getting a square, right? Because this line is parallel to this line is parallel to this line, and this length is equal to this length, and they are intersecting, the diagonals are intersecting each other at origin, right? On the perpendicular, they are intersecting each other at 90-degree angle or at right angle. So definitely it is a square. Now if it is a square, then these are four triangles of equal area, right? So if you find out the area of one triangle and if you multiply that by 4, you'll be able to get the area of the entire square, right? So if you know this concept, then no need to write down all the equation, no need to draw the entire figure, just draw one line, right? Just draw one line, get the coordinates of this point 3 0, then this is 0 2, that means this length is 3, this length is 2, so area of the square will be half into 2 into 3, that is just 3. Area of 1/4 is 3, that means area of the 4 quarters will be nothing but 12, right? So very simply you can do this much work, only you have to do just this much work, right? This is all for the conceptual clarity only. Once you are clear, then no need to draw the entire figure, no need to write down the no need to write all the equations. Okay, now this is a classic question that tests your knowledge of coordinate geometry as well as algebra, right? Now the vertices of the triangle are the vertices where PQR are the roots of this equation. So if your basic algebraic concepts are clear, then you can do this problem very easily. Now the coordinates of centroid we have to find out. So coordinates are x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. If the three vertices are x1, y1, x2, y2 and x3, y3 of the triangle, right? Here the vertices are something different. So the sum of the three coordinates, the x coordinates by 3, sum of the y coordinates by 3, that is these are the coordinates of the centroid, right? Now here what we want, the x coordinate will be pq plus qr plus rq, pq plus qr plus rq by 3, and the y will be 1 upon PQ plus 1 upon QR plus 1 upon RQ by 3. So this can be written as, I'm just writing down the y coordinate over here. We can take LCM, so I'll be getting P plus Q plus R by 3PQR. Okay. Now from where will you get the value of PQ or PQR or this combination? This is x coordinate and this is y coordinate. Now PQR are the roots of this equation, right? Now this is a cubic equation. The coefficient of y square will be sum of the roots in negative, right? Sum of the roots in negative. So sum P plus Q plus R will be sum of the roots in negative, that means sum of the roots is 3, right? So P plus Q plus R is equal to 3. Coefficient of y square is sum of the roots in negative. So here the coefficient is minus 3, so sum of the roots will be 3 only, right? Similarly, coefficient of y will be sum of the roots in pairs, PQ plus QR plus R, PQ, QR and RP. So that is 6. So but that yeah, that we require, no, that, yeah, just that we require, so that is this, divided by 3. So PQ plus QR plus RP, that is nothing but the coefficient of y, so this is 6. Then PQR, product of the roots in negative. So here the constant term, that is PQR, that is product of the roots, right? So negative will be minus 1. You're getting my point? this coefficient of y square is the sum of the roots in negative, and the coefficient of y is sum of pairs of roots, and the constant term, or we can say product of the roots in negative, it's a constant term. So PQR is equal to -1. Now this is what is x coordinate. So PQ plus QR plus RQ is 6 divided by 3. So x coordinate will be 2. Then this is y coordinate. P plus Q plus R is 3 by 3 PQR. 3 into PQR is -1. So it will be -1. So 2 -1, these are the coordinates of centroid. Okay, so the problem is very easy if you are conceptually clear. That means you need to, you must be knowing the concept of algebra as well as coordinate geometry. For coordinate geometry, you must be knowing the coordinates of centroid, and for this particular equation, sum of the roots is the coefficient of y square in negative. This is sum of the roots in pairs, and this is the product of the roots in negative. Okay, so just note it down if you are not knowing this. The extremities of the base of an isosceles triangle is this. If the equation of one side of one of the equal side is this, and equation of other side is, okay, so that is 2 0, this is 0 2, and this is the base. Okay, if the equation of one side is x is equal to 2, now this length should be equal to this length. So if it is x is equal to 2, it should be equal to y is equal to 2, right? So that's pretty simple. The extremities of diagonal of parallelogram are the points this and okay, and if the third vertex is this, then fourth vertex is okay. That means what is happening over here, this is 3 minus 4, this is minus 6 5. These are extremities of one diagonal, and this is the third vertex, that is minus 2 1, and we have to find out this vertex, right? Suppose it is xy. Now we know the basic property of parallelogram, that is the diagonals bisect each other. That means the midpoint of this diagonal will be same as the midpoint of this diagonal, right? So midpoint of this diagonal is this plus this by 2, that is 3 minus 6 minus 3 by 2, and minus 4 plus 5, that is 1 by 2. So this will also be midpoint of this diagonal. Okay, so minus 2 plus x by 2 is equal to minus 3 by 2. So x is equal to minus 1, right? And 1 plus y by 2 is equal to 1 by 2. That means y is equal to 0. So minus 1 0, these are the coordinates of the fourth vertex. Simple. The incenter of triangles formed by lines this and this. Now what we can do is, I just draw a neat diagram, just a moment. So this is the line y is equal to 0, this is the line x is equal to 0, and then I draw 3x plus 4y is equal to 12. So this is this line. Now we have to find out the coordinates of incenter. Incenter, that means there is a circle inside this triangle. Okay, now this is the circle, this is the incenter. This coordinate will be when y is equal to 0, x is equal to 4, so that is 4 0, and this point will be in this line when x is equal to 0, y is equal to 3, so it is 0 3. So this length is 3, this length is 4, so this length must be 5. This is 3, this is 4, so this must be 5. Obviously right angle triangle. Now this will be the radius of this circle, this will also be radius of this circle, this angle is 90 degrees, so all the four portions will be equal. So this is r, coordinate of this point will be r, that is coordinate of incenter I assume to be r, right? That means both the coordinate, that is x and y coordinate, should be same in this case, so we can eliminate two options, right? Now what we have already discussed a formula where there is a relationship between area. So we know the formula, that is in radius, that is r is equal to area of the triangle by semi-perimeter, right? So here area of the triangle is half of 3 into 4, that is 12 by 2, 6, and s, that is semi-perimeter, will be 12 by 2, 6. So r is equal to 1. That means the coordinate of the center are r, that is 1, 1. So this is the correct answer. Okay, I hope you are clear. Orthocenter of triangle with these vertices, though we have already done these sort of problems, one more method I would like to discuss over here. Just draw the simple figure. Now 0, 0 and 4, 0 will be there on x-axis, and then we have a triangle like this. Okay, then we have one altitude from this vertex, that is the altitude. Okay, and one more altitude I just draw from this vertex, so that is this. Okay, now just listen to me carefully. This point is 0, 0, right? This point is 4, 0. This is perpendicular, this is perpendicular. This point is 3, 4, right? Now this is orthocenter. Now orthocenter on this line, right? That means x coordinate should be definitely 3, right? Because this is a perpendicular line to y-axis, x-axis, so x coordinate will be same, right? So if it is 3, it has to be 3, and y coordinate I assume to be a. Okay, now on this line we know x coordinate is 3 and y coordinate is a. Now just see, this is also an altitude, so this line will be perpendicular to this line, right? This line will be perpendicular to this line. So what will be the equation of this line? This line equation will be y, I can find out the slope of this line, or we don't need in fact equation of this line. See, if the two lines are perpendicular to each other, product of their slopes is -1. So slope of this line will be a by 3. Right, and slope of this line will be y2 minus y1, that is 4 minus 0 upon x2 minus x1, that is -1. So slope of this line is 4 by -1, or I can say -4, and product of the slope should be -1. So a is equal to 3 by 4. So y coordinate must be 3 by 4. So it is 3 and 3 by 4. So this is the correct answer. So this is another approach. I have already discussed one approach with you. This is the new one. So just you can use any of them, or you should be having good exposure of all the approaches, right? If the line this cuts the x-axis in A and y-axis in B, then in center of triangle OAB. Similar question we have already done. So I'm sure now you can do this question easily, and this is the line that we are having, this that is 3x plus 4y minus 24 is equal to 0. Then we have this as a circle. Okay, now coordinates of this point will be when y is equal to 0, x is equal to 8, so this is 8, 0. When x is equal to 0, y is equal to 6, so that is 0, 6. So this length is 6, this length is 8, that means this length must be 10. Again coordinates will be r, r. We have just discussed this question. So again we'll be using the same funda. Area by semi-perimeter. Area is 6 into 8, 48 by 2, 24. Semi-perimeter is equal to 6 plus 8 plus 10, 24 by 2, 12. So R should be 2. So answer must be 2, 2. Simple. Area of the triangle with vertices this. So I just draw a rough figure over here. Now minus 4 1 somewhere, minus 4 and then 1 somewhere here. Okay, that is minus 4 and 1. Then we have 1 and 2, so this is something around 1, and then if this length is 1, so 2 must be somewhere here, so it is 1 comma 2. Okay, then we have 4 minus 3, so this is 4 and this is minus 3. So we got this triangle. Now you have two options. You can you should not draw the diagram and just try to find out the area using determinant method. The other way is you draw the triangle and then just see this. See, what I do is I just draw a line like this up to the last point. Okay, then this, then this, and then this. Now you can very well see a rectangle. So from this rectangle, if we deduct the area of this, this and this, the three triangle, we can get the area of this particular triangle, right? Now that's very easy for us to do. See, from this point to this point, the total length is, this x coordinate is 1 and here x coordinate is 4, so this length is 3. Over here y coordinate is 2 above and y coordinate is 3 below, so this total length is 5. Okay, so area of this triangle will be 5 into 3, 15 by 2, that is 7.5. Okay, similarly this length, that is 1 and then 3, so that is 4, this length is 4, and from this point to this point the total length is 1 this side, 4 this side, and 4 this side, it is 8. So half of 4 into 8, that is 16. Okay, then this length, this is 1 and this is 2, so this length is 1. Then this length, this complete length, it is 4 this side and 1 this side, so this complete length is 5. So 1 into 5, 5 by 2, 2.5. So this is the area to be deducted from the area of this triangle. So that is 26 actually that we need to deduct. Now area of the triangle is, this is 8 and this is 5, 40. So 40 minus 26, area of this triangle will be 14. Okay. So this is very easy, simple approach that also can be done, and you can very well use a determinant method. But this concept should also be clear in your mind. If the coordinates of these points are respectively, then the area of the triangle ABC. One more problem we try in the similar manner. Definitely determinant method can be done, but you just practice with this method also. So whenever you have some simple data, you can use this method. So 4 and 4, 4 and 4 somewhere here. Then we have 3 and minus 2. So 3 and minus 2, 3 somewhere here, and this is minus 2. Then we have 3 and minus 16. So that is maybe you can say somewhere here. That is 3 and minus 16. Okay, so our triangle will be something like this. Now in the similar manner, I can try this problem. This is a straight line, so I just extend the straight line like this, then this. Now in this case, no need to draw the rectangle, right? This is a right angle triangle. Okay, from this entire big right angle triangle, if we deduct this right angle portion, then the remaining will be area of this triangle. So this entire length is from 3 this entire length is minus 16 and 4, so this entire length is 20 and this length is 1, right? This is 0.3 and this is 0.4. So the area of this bigger triangle, that is this triangle, will be half of 20 into 1, that is 10. And still we have to deduct area of this. So we can have any option that is less than 10, so that is just 1, that is 7. Okay, still we'll calculate this. So this length is 1 and this length is 4 up and 2 down, so this is 6. Okay, so area of this will be half of 1 into 6, that is 3. So this way you can calculate the area very easily. Okay, so the area of this triangle is 7. Now area of this triangle, now the earlier method is clear in your mind. Now I just use the determinant method, so that is 1 minus 1, 1 minus 1, 1, 1 minus 1 minus 1, 1, right? So here it is 1 into 1 plus 1, okay, 1 plus 1, because minus 1 into 1 will be minus 1, but actually it is 1 minus 1, that means this into this minus this into this, so 1 plus 1, it is 2. Then we'll have negative sign of this, so that is plus 1. Then we have minus 1 and plus 1, that is 0. Then we have 1, then okay, plus 1 plus 1, 2. Okay, so 2 plus 2, that is 4, and half of this will be 2. So area of this triangle will be 2 only. Okay, so this way also you can do. Determinant method I have explained, and the previous method also I explained. And how the other method is used for this question, that also I just explained. Just draw one line, axis, 1 minus 1, so that is 1 and this is minus 1, right? Then minus 1, 1, so this is minus 1, 1. Then we have minus 1, minus 1, so it's minus 1, minus 1. Okay, so this is a straight line, this is a straight line, so they will be perpendicular to each other. So you just have a right angle triangle. So this length is from minus 1 to 1, this length is 2. From minus 1 to 1, this length is 2. So half of 2 into 2, that's 2. Okay, this is the other way. I hope you are clear with both the methods. You just have to observe one thing, that in this case the x coordinates are same, and in this case the y coordinates are same. That means this line is perpendicular to this line, right? This is a straight line that is perpendicular to this line. Okay, so we got a right angle triangle. Okay, area of triangle ABC is 20 units and its vertices are A, B and this. If the third vertex C lies on the line this, then C is equal to. So difference between x and y coordinates must be 2. So bright chances are there. See, this is deleted. This 3 and 5, this cannot be the correct option because x minus y must be 2. This can be the correct choice, but let's draw the figure. Minus 5, 0, so this is probably minus 5, 0. Then the second one is 3, 0, so somewhere here it is 3, 0, and the third vertex is on this line. And apart from that, we can just see if this is the third vertex or not. So we can calculate the area of this triangle and equate it to 20, whether we get 20 or not. So I start from this, minus 5, 0, 1, 3, 0, 1, minus 3, minus 5, 1. Okay, so it is, it should be 40 because half of that should be 20. So minus 5. This into this, minus this into this, so it is 5, then this cancelled, then plus 1, minus 15, only minus 15. Okay, so it is minus 25, minus 15, that means minus 40, modulus will be 40, 40 by 2, 20, so this is the correct option. Okay, so this is one more way to solve the problem.